Here's an iPhone 11 that does not activate because it has a baseband issue. It also doesn't have Wi-Fi. And this is because there's a sandwich separation issue on this motherboard. And in today's video, we're going to walk through how to repair it so we get a fully functional phone that includes splitting the sandwich, reballing, the whole process. So hi, I'm Jesse from VCC Board Repairs. Thanks a lot for joining us here on the channel. If you like these type of videos, make sure you smash the like button, subscribe to the channel, and share this video with all your friends. Also, don't forget down below, I will link to all the tools I'll use in today's video, as well as this t-shirt, Will Fix Your Phone for Bitcoin. So if you like cryptocurrency, this is a good shirt if you're doing repairs as well. So let's go ahead and get started with this repair of a sandwich board. So let's go over the symptoms of this device. So this is a phone that has been restored. As you can see, there is no networks available for Wi-Fi. I do have everything plugged in, so it should be picking up Wi-Fi, but there's nothing here. Now another thing you can do is, since we cannot connect to Wi-Fi, we can't activate it, but you can try to activate it via USB. So I've now connected it to the computer. And here on 3U Tools, what you can do is, if you click refresh, after you have it plugged in, you'll see that the IMEI field is empty. Also, if you just look at the device as well, if you lock the screen and unlock it, click the little I here, there's no IMEI, only the serial number. So that points you to there being an issue already. There's no IMEI here, there's no IMEI on the device, and there's a button here, activate now. So this is the same as if you were to connect to Wi-Fi and then click next, and then it tries to connect with the Apple servers. It'll come back with unable to activate with the big exclamation mark. This is the same thing right here. So any iPhone that does not have a working baseband or has an NFC issue or could have some other issue causing it not to activate. Also, if you have the wrong serial number program, so if someone for some reason changed the serial number on it, that could be what's happening. But in this case, it has no IMEI, which tells us there's a baseband issue. What that means is baseband is a cellular circuit. The cellular circuit is not working, and you restore the phone, it will not activate because it needs the IMEI to check in with the Apple servers, and the Apple servers don't get an IMEI, so it cannot activate the phone because it's an iPhone, should have an IMEI. Otherwise, I guess they reject it for whatever reason. So let's go ahead and get started with the actual motherboard repair. Also, one quick note is this housing looks in really good condition. It doesn't look cracked. It doesn't look smashed. Although it does have a smashed camera lens, the housing itself overall is in pretty good shape. And it does look original, although it could have been swapped out. But if there's any signs of physical impact on the housing, that gives you a clear sign that the motherboard is going to have an issue. So if we now go under the microscope, what I like to do first is, when inspecting the motherboard, is look at it from the side, see if there's any obvious separation. iPhone 11s, starting on iPhone 10 and newer, the motherboards for iPhones have been sandwich boards, meaning there's a top layer, bottom layer, and this interposer, kind of like a spacer. And what happens is the bottom board has the baseband circuit, Wi-Fi circuit, and the top board is the main board. So if there's separation between the two layers, what will happen is it loses communication to different functions like baseband and Wi-Fi. So physically it looks fine from what I can see here, although you kind of see the solder joints right here. If you look closely, you can see all those solder balls, and maybe that's where the issue is. But we won't know until we actually separate the two layers and see if there's any kind of damage to the pads. Since we have to put it in a heater, I like to take these off because these will melt and wrap around the connectors and kind of just get in the way when you're trying to plug stuff in. So I like to take them off now. By the way, I don't recommend you just try to do one of these sandwich repairs on a customer's phone. They're a little tricky to do, so definitely practice on like non-working iCloud boards, or just working iCloud boards. But all right, so this is the heater I like to use, the Mechanic 5 Max IX5 Max. I will link this down below in the description. It has support for iPhone 10, 10s, 10s Max, and then iPhone 11, 11 Pro, 11 Pro Max. So this upper part is for the 11 series, the bottom part is for the 10 series, 10s series. So there's only an on and off switch that is on the power cable itself, which I flipped on, and it's just on and off, and there's a light here to show you that it's on or off. So there's no temperature setting or anything. It just, you place it there and you wait. Usually it takes about 5 to 10 minutes. I'll see if I could time it, because I never really timed it. I just keep an eye on it and see when it's pretty hot. So just let this sit and then we'll be right back. All right, so it's been about 5 minutes or so, maybe 6, and it looks like it might be ready. So one of the things I like to do is, well, first of all, I don't really clip these on because I don't feel like it's necessary. Although if you do want to clip, use these little handles here to hold it in place, you can, although it's fine without it. So one of the things I like to do to check if this board is ready to split is I use my tweezers and I push down to see if there's any kind of movement. Because there's solder joints between the top layer and the interposer, if the solder is melted, then I know that the board will squish together. The solder itself is very minimal, so it won't bridge anything, it won't short anything out. So you can do this. And essentially, I also look for any kind of flux from the factory kind of ooze out, which might be hard to see on camera. You kind of see it here. I just saw it. You kind of see it there at the top. If it does ooze out, that means the solder has flowed into a liquid, and you can split this. Okay, so easiest way for me to split is I go from this corner here. I know there's a bunch of ground pads, and what I like to do is, whenever possible, if I don't need to physically reball it, and I can just reuse the factory solder, I do that, but it just depends. So in this case, let's go ahead and try it. What I'm gonna do is insert my fine tip tweezers. This is a Tool 3D tweezers. Highly recommend these for board level repair. Once you insert your tweezer enough, the board should separate, and then you could move it over and flip it upside down. Now we can inspect the board, and we can see this is what the inside of the sandwich looks like. So what I'm going to do is, I do see one rip pad there, 2, 3, 4. I'm just doing like a visual inspection of the board. Yeah, so basically 4 pads. So before I turn off this heater, I'm going to just remove these 4 pads. These are 4 pads from the top board. So I just grab them. And then I stick my tweezers into the brass wire for where I clean my soldering iron. So that's 2, then 3, and number 4. All right, so now I can turn this off. So one common issue is if you have a baseband issue and you split the sandwich, first thing I check for is this chip, see if it's physically cracked. From what I can tell, is not. Otherwise, you usually see a line. I believe either up and down or left and right. I think it's up and down. But you'll see a crack. Since the chip is underfilled, it tends to crack for whatever reason. Also, just check for any other chips that are cracked or loose coils. Every once in a while, I'll find a loose, broken coil down here. These are fine. This is baseband power chip, baseband PMU. This is baseband CPU. So this is like this is what powers the main baseband CPU, the cellular function. And I always like to clear out this thermal paste or compound. So just gently with my tweezers, kind of go like that, scoop it all up. But be gentle not to break anything. And you also don't want to get this stuff on the solder joints. So with this stuff removed, I'm going to literally throw it in my trash can underneath. Now I've done hundreds of these repairs where I remove this thermal paste and I don't have any issues with overheating or anything like that. The main reason I remove it is because I don't want to get it on my solder joints for the sandwich. So just get as much as you can. It doesn't have to be perfect. So also this is NFC here and this is Wi-Fi. The chips that are paired to the main board is Wi-Fi and baseband and EEPROM for baseband. So if you're going to do a bottom board swap, which means if this bottom board is damaged beyond repair, you can transplant this, and EEPROM, this little chip here, onto a new bottom board, which will get you a working bottom board. Now NFC is only required if the board has Apple Pay configured. If they have Apple Wallet set up, then you're most likely going to have to transfer this or deal with a screen where it says like swipe up to recover, and then you have to wait like 15-30 minutes for that process to complete. Or you can transplant NFC and then not deal with that. Although this is underfilled, so it's not practical to transplant. But what I've noticed is most people don't have Apple Pay set up, so it won't be an issue. And they should be able to set up Apple Pay after, although I've heard that you can't, so I don't know. But I haven't had any issues doing it the way I just explained it. So if you look closely at the solder joints, they're now cooling down. They're no longer super shiny. When they're like more like a matte color or dull, that means they're no longer a liquid. Now see, I could poke the solder joint and it doesn't they don't move. So yeah, this has cooled down enough. Also, what you want to look for is the little disc spacers like this one. Sometimes when you lift up the board, these little spacers that come from the factory will end up sticking up. Then when you go to place it, when you go to place the top board back on, it won't sit flat and it will mess up your install. So okay, so far, yeah, everything looks good. So because the bottom board appears to be fine, I'm gonna go ahead and just clean it and basically have it ready to test with for the next step. So I'm gonna use these little cotton sponge Q-tip things. And the reason why I need to clean it is because we're gonna test in a sandwich jig. If you're gonna do any sandwich repair, definitely buy sandwich jigs for the model you're working on, because otherwise you're gonna be wasting a whole bunch of time testing by soldering the two layers together, where the sandwich jig lets you test the two layers together without spending the time soldering it. All right, so now I've cleaned up the pads. As you can see, it's, well, I'm gonna clean a little better. The goal here is to have it nice and clean. You can see how no more flux. It's fine as a minimal, but the idea is to have it clean. Okay, so let's put this off to the side. Now let's focus on the top board. So I'm going to use my Mijing K20 Pro, I think it's called. I don't know, the name has gotten messed up now since I use it so much. I think last video I called it K20, but I think it's K23 maybe, I don't know. All right, so this has thermal compound as well, so I'm gonna use my blade to scoop it out. That way it doesn't accidentally spill over onto the pads and then make it real difficult to clean afterwards. All right, so same thing here. We're gonna clean off any flux. I wish there was a preheater for top boards, for sandwich boards, because it makes things easier when you're applying flux or trying to clean off flux. Easier to do it hands-free versus applying any hot air. And just working with anything that's underfilled, you know, a preheater helps with that. Otherwise, we have to use a board holder like this, and then, you know, everything's room temperature. Okay. I think I was trying to pick up any kind of lint that was left behind. Although the lint itself won't really cause any harm. All right. Some more alcohol, and then just use my little clean cloth. Let me know in the comments, how do you guys clean the boards you're working on? What do you use? I know some people use like this chemical called MEK, M-E-K. I know some like acetone. I use isopropyl alcohol. All right, so now we're gonna visual inspect the board. So there's one pad here that looks really dark, but I think it's just the angle of the lighting. All right. That's just flux. Yeah, so that wasn't cleaned perfectly. If it was on a board heater, definitely would clean better. So these are some RF chips, probably have to do with cellular. This is the main audio IC. This is chestnut. This is the charging IC. I think it's called charging IC on this model. PMIC, this is the main power chip, the CPU, camera, PMU, and I think, I don't know what this does. I think it's Face ID maybe. All right, so on this board, we're gonna have to fix a few pads. So I guess this video is also gonna include that. First, we need to see if these pads are critical. One of the nice things about these models is these 3 little dots are super easy to expose and scratch out. So let me scratch out a little bit. So we have that one. We have these 4, I think it was 4 or 5 pads we need to fix. So I'm just scratching out a little bit so I can probe them. And then the rest are fine. Okay, so let's see. Are any of these pads critical to replace? What I like to do is check if they're shorted, if they're ground pads, by checking to see if there's a short to ground. So I'm gonna put my multimeter into diode mode here on the top right. My red probe is gonna go on ground. I like to use the top of this metal chip or this one. And then my black probe, I'm gonna probe the line that I'm trying to check for. So this one reads at 0.000, so that's definitely ground. This one, 000, that's ground. 000, ground. 0.029. So this one's probably an actual line, because the ground line should be 000. So what I'm going to use to show you guys to confirm this is we're going to use the REFOX Bitmap software. This is kind of like ZXW. It's a Boardview software, but it is also a schematic software. It's not free. You do have to pay for You could do 1 month, 1 year, or 1 year for 3 devices, I guess. So if you have like 3 computers, you want to share the account. One account for 1 year is 56, which is definitely reasonable. One repair should be more than enough to pay for this. So, and one of the nice things about this software versus ZXW is if you want to buy it here within, renew it, you just do it right here through the app. Whereas ZXW, you have to buy it from a third-party site, and you get this code. Sometimes they don't automatically send you the code. You have to wait for the rep at that store to send it to you. This is instant here within the app, so you can just sign up and be ready to go. You can do PayPal or credit card, so up to you. And then just submit payment and then get the code so you can reactivate. So here's where you put the activation code. So you buy it through here, they email you a code right away, and then you apply it. So that's real good. So here on the left is the models. So you could set up a favorites page, which I haven't. If you want a free account, I guess they do give some devices that are free, so iPhone 8 and older. Bitmap is basically Boardview, so we have iPhone 11, this one. By the way, you could download this software at the refox.com site. I will link it down below in the video description. And one of the first things I did when I got the software is I went to settings, go to color templates, and I changed it to common. The default color is ugly. That's just my personal opinion. But I didn't like it. It's not that one. I think it was, yeah, it was this color. When you first download it, definitely change it to common because that just looks really bad. This is way better look to this. Let's see. So right now, you have all 4 sides. The top side is this one and this bottom one. Then the bottom board is, top side and bottom side of the bottom board. So we're actually working in this area. Now, one of the things I wish this software had is that you can pull this down further, because sometimes I want to, have this in the middle of the screen, but it stops right here. Like I can't drag it down further. So I know, first world problems, but ZXW lets you do it. So that's kind of like my benchmark. I do like ZXW. I've been using it for years. And any other Boardview software I ever used, there's always something I don't like about it. And this is one of the things. Also, if you zoom in, you'll see a few things. You see the pin number, or the number of the pin, the name of the line, and then this is the diode mode reading. I do wish this diode mode reading was bigger, because like sometimes I have it this zoomed out because I want to see like the whole row. And the number is tiny. It's real hard to see. And you zoom in and it shrinks even, it stays the same size no matter how far you're zoomed in. I do have a 4K screen, so that maybe that's why the text is so small, but there should be an option to fix that, which I don't see it anywhere on here. So yeah, that's just my recommendation. So let's take a look at how we have the board laid out. All right, so here on the right is the CPU, but here on the Refox software, we have the CPU on the left. So let's rotate this. There's rotate buttons here. Click it twice, and now here we go. So here's the CPU on the right side of the board. Let me scoot this over. Yeah, see, if I was able to drag this to the left, I'd be able to put it in view, but I can't, so I have to physically move the software window. All right, so this is the area we're looking at. So here's going to be the tricky part. So how do we figure out whether these pins need to be fixed, these pads, or leave them as is? Because if they're ground pads, they're not required. If they're not ground pads, then you probably should jump them. So here is probably the pad that's ripped, just because if you zoom out, you see there's a ton of ground, and just like in the middle of all this ground, there's these 4 pads. So one easy way I like to do is just diode mode to find these 2, and then we know kind of relatively, like we know just by reference that if I find these 2 pads, then the 2 to the right above them are going to be the ones we need. So let's switch over to the full screen, and then red probe on ground. So here's one pad, here's the other. So 487, 487, and then a bunch of ground around it. So these 2 are the 2 bottom yellow ones. So this one and this one are the 2. They're not ground, but they do have a low diode mode reading. So my meter still beeps, even though they're not technically shorted. So we go back over here. So these are the 2 that I found. This is the one that's ripped, so I definitely need to repair it. You can see the diode mode reading is 16. So my multimeter I get 25, so pretty close. It definitely is a pad that probably should be fixed. So to fix this is pretty simple. I like to drop alcohol on the board because it makes things easier to see. Although for you guys it might be a little harder because of all the glare. I do have a polarizer light that does help with the glare, but it does turn everything darker. And if you drop alcohol, get a sharp number 11 scalpel blade. And essentially what we're doing is scratching out between the 3 dots. Essentially we make a little triangle out of those 3 dots and essentially create a pad out of it. So something like that. So there's 3 dots, and then we just scratch out and kind of make a little triangle out of it. Then put a little flux, get some 183 Celsius solder. So this is just regular leaded solder. Tin it. Then we use the Refox Soldering Lugs. So I will link these down below in the description as well. I do have a separate video on this specifically, the solder lugs. Although this is I think my first video showing how to use these solder lugs. And one of the nice things about these is how easy it is to repair. So the trick is to place the solder lug over the tinned scratched out pad that I did. Trying to line it up as best you can. Hold it with your tweezers, and then with your micro pencil, I'm using a J-tip, just tap it real quick. And that should flow the solder from the part you tinned through to the pad itself and essentially reform that pad. Now I'm going to scoot it up slightly up because I felt like it was too close to the bottom. Now that we've done that, we have fixed the pad. So imagine if you have 10 of these pads ripped, how quick it is if you just prep them all and then just go to install each solder lug. You can't even tell there's a pad missing. Okay, maybe you can tell, but if you're watching this video, you saw me fix a pad, but you can see how it kind of just blends in, and that's the whole point of the solder lug. Now to secure it so it doesn't come loose, I'm going to use some UV mask. This is some what the Chinese suppliers like to call green oil. I just push out just a little bit, oops, like a little bubble, scoop up some with my blade, and then when I have my blade, I use my tweezer to tap the blade and then scoop up a little bit UV. The goal is to kind of coat around it. Make sure the UV gets in the little crevice in here. Make sure it's as flat as possible. Don't create a little mound, because then that's gonna throw off the spacing that you need. So if you put too much, just spread it around so it's flat. And then we're gonna cure it. So I'm gonna use UV lights, and then essentially just place the UV light on top. Meanwhile, let me show you how. So then I put away the UV mask, wrap it in this towel, and then put this off to the side, because that stuff is really messy. So UV light only needs maybe 10 to 30 seconds for it to fully cure. I do recommend you don't look at it straight directly through a microscope. UV light is bad for your eyes. So while we let this cure, let me kind of show you a little more about the REFOX Bitmap software. I did post about this in my Facebook group. If you're not in it, it's also linked down below. It's the phone repair community. So the Bitmap software has all these iPhone models. So iPhone SE 1, 2, iPhone 5S, 5C, 6S Plus, basically all the modern iPhones you're gonna be working on. It has iPads. Let's see, iPad Air 1, iPad Pro 9.7, iPad Pro 9.7 4G. Yeah, I mean, you might as well just pause the video and read this through. It's a big list. Oh look, it has some MacBook stuff. I don't do MacBook repairs, so don't ask me about this. Even some iMacs. But here's the board numbers if you need to know what MacBooks it has. Samsung, so it has J series, J510, N series, Note 3, S8, S8 Plus, S6, S5, W series. I don't even know. Never heard of Samsung W series. Some Huawei, Xiaomi, Vivo, Oppo, Meizu, and OnePlus. So these are the board views, what Refox called bitmap, like what you're seeing here. This is a board view. Board view is like literally the board and then the related information to it. So like if you zoom in under an IC, you get all the diode mode readings, 343, 535, 299. This is the pin number, the name of the line. Just you hovering over it also gives you the information about it. Oh, you know what? This is pretty cool. I just noticed it. So if you click on a line, and then here on the left gives you all the components that it's connected to. So you can kind of browse through that. So let's say you're trying to track down how something's connected to something else. Let's say this one, PPBAT-BCC, Yancy, maybe it is Yancy. So you get the IC, you get the pads, the caps, the resistors, the coils. So that's pretty cool. I never noticed that. If you zoom in under an IC, you get the diode mode readings, which is huge. Now, from what I've seen, diode mode readings are always going to be hit and miss, especially on iPads. Let's see, let's go to iPad Air 1. There it goes. And one of the nice things is there's tabs. So if you're working on two different devices, you could also, switch between them. So this is iPad Air 1. Let's see, diode mode readings of the digitizer connector there. I believe this is the LCD connector. It does have diode mode readings. Net names. So down here you see the net names. Is missing the component values on this one, so you put the mouse over it's a filter, although they start with L for some reason. You could also, by the way, if you double click on something, you can manually enter your own diode mode value. So if it doesn't have it, but you have the device in front of you and you have a known good, you can manually add in your own. For example, let's say I know this reading is 0.350. Oops, confirm. So, all right, well that, I'm not sure what happened there. Well, diode mode reading disappeared, so I honestly never tried it. Yeah, this is 0.35. Maybe I put 350. Yeah, it has to be 0.350. Save the resistance, okay. But where did it go? Oh, yeah, so up here there's a diode mode value and a voltage value. So diode mode value is when you're doing just diode mode. Voltage value is when you are powering the device and need to measure an output voltage of a certain line, which is a little trickier, can be a little more risky because you have power, and let's say you accidentally short, like your probe slips and you accidentally probe, these two together, and you short the line out. It's probably not good. But yeah, see, here you go. This is where I was supposed to put it. 350. Oh, it has to be all right, resistance voltage, okay. Yeah, there you go, see? So yeah, you could add your own diode mode value here. I mostly use diode mode values. I know some people prefer, measuring voltages. You can do either or. Let's see what else do we have. There's also schematics. So if you want to be working on a board, let's check iPhone 11. Oops, iPhone 11. So if you, here on the left, if you pick schematic button, oops, if it goes away, just click one of these buttons here. I guess this one. So if you want to look at just the schematic, go here and click iPhone 11 schematic. It'll pull up the schematic like PDF. So one of the things I don't like is when you use a scroll wheel, it scrolls down, but if you scroll up, it zooms in. So it's kind of weird. You can drag it up and down. So one of the benefits to schematics for me is if I just want to identify a specific chip, I want to know the actual name of the chip or the circuit. So you can probably search it here too. Let's try it. Chestnut. I don't even know if I spelled it right. The chestnut? I guess no T. Chestnut. And nothing came up. Let's try. Yeah, well, maybe I should search for stuff I could spell. All right, so Yancy. You see the search results here. All right, you can see the different lines. So yeah, so there you go. So this chip, U3300, is called Yancy Charger. That's the name of the chip. Oops, yeah, see, I don't like this scrolling wheel thing. Because when you zoom in, you could scroll the wheel up and down. But once you reach the end of your zoom, then it starts scrolling down the page instead of zooming in, which is kind of annoying. So yeah, if you ever want to know the name of a line, what a chip does, so there's some random chip. Now I've used JCID software, and that one you can double click on a specific component or line, and it'll show you both side by side. This one doesn't. You have to manually go and set that up. So you go to double view, and I'm going to do iPhone 11. So I've done double view, and now it's working. So let's say I want to look at the charger. All right, let's do Hydra. So I click on the chip, and immediately it pulled up Hydra, which is this chip. If I click on a line, it will also highlight that line on the schematic. So this pad here on the board view is this pad here on the schematic. So Hydra, so let's see, there's some chips I don't know what they do. So if we go, I was showing you guys, there's a small chip. So this is Chestnut display PMU. There's another chip somewhere here. What does this one do? This is Gecko. I don't know what Gecko does. You zoom out, it doesn't say. Let's see, Gecko. What does that do? I have no idea. Some data lines, some I/O lines. It's powered by VDD main because it's here at the top. It outputs ACC var variable, I guess. So is this an accessory kind of chip? I don't know, usually. So the real schematic PDF will usually have a thing here in the corner that tells you the kind of function of it. So I don't know. So Muon, I guess, is the backlight. So double click on the chip here and it highlights it here. So that's kind of how you would use this. Any component you click on, it'll highlight it here on the schematic. Click the test points. So there are different test points. The connector. So yeah, I mean, the software is pretty cool. I do like the user experience, like the navigation. I just don't like the schematic part where you zoom out all the way and it scrolls the pages, scroll up and it zooms in, and then it's kind of weird. I wish it was more like a PDF functions where you had to switch between, you know, dragging or scrolling. Another downside to this, well, these that I haven't figured out how to do, is how to enable the layers so we can see the different layers between the motherboard. All right, I'm in double view, that's why I keep switching. If we go back to bitmap, iPhone 11. Oh, it's still in double view. How do I turn that off? All right, let's try. Let me close all these tabs. And let's try to open it from scratch. All right, there it goes. So I guess you got to close all the tabs. Do it again. Let me see. If I click double view. Yeah, see, it won't open the schematic automatically. You do have to manually go and do it yourself. There's also repair cases. So like basically solutions, although I don't know how useful these are. And I believe they're in Chinese. So unless you speak Chinese or just want to go off of the pictures. Oh, look, it is in English. I know I've opened a few of these before and it was in Chinese. Also don't like how it automatically full screens your screen. So yeah, I guess some solutions, what to check. I don't know. That's up to you if you want to use that. But yeah, that's kind of the main thing. Now keep in mind, there are going to be some devices that don't have some information, like some may not have diode mode values. Like I know certain iPads just won't have it just because nobody has it. But the benefit is you can kind of program your own into it. So if you have a known good board, you want to spend the time to do it, you could add it yourself, I believe. So let's say this connector or not. You gotta right click. Yeah, you could just right click. And the other one you could just double click. Okay, you could do that now too. But yeah, I don't know. I think it's pretty cool. I just wish it had the layers so you can see how. Uh-oh, why does it keep popping up for every? Maybe this is a bug. That's it's annoying. Oh, and resistance. Okay, so for some reason you enter edit mode, and then you can go and add in the diode mode values, and then you have to manually right click and end it. So yeah, that's pretty much the situation here. So let's go back to this phone. It's been more than 30 seconds, so this should be fully cured. Then you get your blade and scratch out and expose the pad. And basically now it's like nothing ever happened. So let's now test out the board with the sandwich jig to see if it's fixed. All right, so what I'm gonna use is this sandwich jig. This is the Mega Idea iPhone 11 sandwich jig. This lets you temporarily connect the top board and the bottom board, which I have the bottom board over here. Best way to determine which side is which is one side has 2 tabs, the other side has 1, and match that up with the screw hole like this. Then you get the little spacer. I manually wrote, which side is up, just so if I ever mix it up, I don't put it in the wrong way. And then also, use this little space to help you align this so that you're good. Also, I like to push down and feel that springy effect, so I know it's lined up and it's good. I put the top board, and it definitely has some spring to it. So you can see how it's the bottom board, the spacer, and then this top board, and it's connected through these little pogo pins. So it essentially creates a temporary connection between the top and the bottom. All right, so that's maybe the wrong way. There you go. Yeah, so when you're gonna clamp this down, press down and see if it goes in smooth. If it doesn't, it means you probably have it misaligned or in the wrong direction. iPhone 11 specifically, because it's like symmetrical both ways, just a rectangle, it's easy to put it backwards and not know, and possibly you don't want to break the board. So this is how it goes. Then we're going to use a charging port. Battery and the customer screen. We're going to use the customer screen just because it works. Normally I'd use my own screen, but in this case, we're not dealing with screen issues. So, and then funny enough, I do use this TriStar tester as a stand for my battery. Otherwise the battery will be hanging off and it will most likely fall off. So iPhone 11 battery, I'm gonna plug it in, and then it sits on the TriStar tester. Then I'm gonna use my USB cable to prompt the boot. Now keep in mind, this phone will restart every 3 minutes unless it's being updated or restored without a power button. So if you're doing any kind of long-term testing more than 3 minutes, definitely plug in the power button here on the bottom. Otherwise, you don't need it, because once you start the restore process or update process, then you don't have to worry about that. Okay, so 1 second. Okay, so here on 3U Tools, you'll see that, oh look at that, IMEI just came back on its own. So that means something's working. So if we go here and let's see if we get any Wi-Fi networks. United States, set up manually. We're probably not going to see any Wi-Fi networks, but if I manually go to my phone and set up a hotspot real quick and put my phone right next to the motherboard, I might picked up my Wi-Fi network. So you can see Wi-Fi is working and IMEI seems to be working. I've actually never seen the IMEI not be there. I fix the board and it comes back on its own. Usually if you restore it and it has a baseband issue, it's not gonna come back until after. So let me try this. Let me activate start. If I get a green message that it went successfully, that means we had 2 potential issues. Look at that, it activated. So if we go, all right, so click OK. So next, continue. So normally, if the device has a baseband issue and you restore it, you're essentially wiping the IMEI from the operating system. So in order for it to come back, you have to restore it again once the baseband issue is physically fixed on the motherboard, and the software has to basically restore to check again for the IMEI and write it into the system. But in this case, this is my first time ever seeing that happen, where IMEI was definitely missing, as you saw in the beginning of the video, and now it's back without a restore. Maybe just a weird glitch or something, but here you go. So Wi-Fi, you could turn it on and off, it's not grayed out. Bluetooth, you could turn it on and off. And there goes the 3-minute restart. So that's actually normal. So being that the board is working now, I'm going to assume it's all good. So now we know the 2 layers are good. So now we got to stick the 2 layers together to get a fully working phone. But what I was trying to say before I got sidetracked was most likely the issue was not necessarily the rip pad, but just a hard drop or a bend of the housing caused the, I'll show like this. So normally these should be soldered together, but any kind of drop or impact will cause these to separate, causing it to lose connection to the Wi-Fi baseband chips. So the main board, the CPU, can't talk to these chips, therefore it has issues with activating and all that stuff, no service. You'll get a cellular update failed message. So if you go back over here, most likely it was just cracked solder joints, and it didn't need any extreme type of repair, like a bottom board swap or an actual reball. So what I'm gonna do is I put this on the heater, I turned on the heater, and here's my secret sauce on how to do these quickly. Although this video I think is probably gonna be long, especially with the explanation of the Refox software. But usually if it was what I just covered today, I'd probably be able to fix this within 30 minutes to an hour. Because the steps is really just split the sandwich, check for any rip pads. If there's any rip pads, fix the pads. Then test in the sandwich jig. If it's been restored, it might require another restore in the sandwich jig, when we know in the sandwich jig it will for sure make contact with all the pads. All right, let me line it up. What the flux there gives me time to line it up and then press it down. So yeah, basically my process is split the sandwich, check for any rip pads. If any rip pads, fix them. If not, then ignore. Clean the 2 sides, put it in the sandwich jig, test it. If it works, great. If it doesn't, restore it, assuming it's restored. So don't restore it if it's not restored. If it is restored, then you have to restore it again, most likely, once you have it in a working board state. And once you're able to activate it on 3 tools, then the board is all good. Test the main functions you can, and then sandwich it back together, and you should have a fully working phone. By the way, if you need this repair done, send me a message. I'll have my contact information below. I do accept mail-in repairs from all across the country here in the US. I'm located in Las Vegas, Nevada. I do offer B2B as well. So if you're a repair shop and looking to outsource this repair to us, not a problem. We actually specialize in B2B repairs for repair shops. So what I've done is Essentially, while the board is getting warm, I applied flux all around the perimeter over all the pads. I lay down the top board and try to align it as best I can by using the screw posts here. Well, that one you can't see through it. And then essentially now it's time to wait. So we'll be right back. Okay, so it's been about 5 minutes. You always want to wait a good 5 minutes for the solder to melt. And essentially, once you start seeing like the smoke from the flux burning away, that's a good sign that it's ready to go. So what I like to do is physically look at the board from the side and see if I can see the solder, not the solder, but the sandwich kind of squished together. And I just kind of go down the middle of the board. Now, I do kind of see the board slightly warped. I do see there's a bigger gap. If I look at this from the side, on this side versus this side, it's sitting flat. There's like a little gap on this side. So we'll see. All right, so because it's kind of warped, I'm going to do this. I'm going to actually use some a weight. So the amount of solder that's on each side, the volume is so low that when you squish it together, you know, the pads are far enough away from each other that you're not going to squish solder where they spread and bridge together when you have the factory solder. If you actually went through a reballing process with a reballing jig and you do squish it, you're going to have a lot more volume per pad of solder. Now when you go and squish it, you're actually going to squeeze out solder balls. So only do this if you're using the factory solder. And I'm going to put these little shims here so that it has a flat surface to press down. And then I'm going to use my little steel block. Oops. And I'm going to literally, well, let me turn this off. And I'll put my steel block so it applies pressure evenly and presses it down. And we'll give it another 5 minutes to cool down. And hopefully it'll be a fully working phone. All right, so it's been a good, I would say 10 minutes maybe. So I'm going to remove this block, steel block. I'm going to push down to see if I see any movement. I don't see any movement. So this is probably good enough to test. Take these off. One of the nice things about the iPhone 11, it has this little handle here that you put your tweezers under and can lift it up. Once you lift that up, you can essentially lift up the whole board, get it out of the heater. So now we can do a visual inspection. Okay, so it's still pretty hot. So I'm gonna use some tweezers to hold it. My little sideways board holder. Okay, so you can actually see the solder joints are real nice looking here. You can see there's no large separation. The solder joints look soldered together. And the real question is this going to work? We don't know until we test. All right, so no gaps. So this should be good. Now before I do that, there is some flux underneath here. So I'm going to clean this. Now this is just a sticker on the bottom, so it might wipe away some of the top layer of it. I guess not. Also, let me clean the sides just for good measure. I don't like leaving a board full of flux and all nasty. I think it looks very unprofessional. So whenever possible, I do clean the board as best I can. Although you can never really get it perfect unless you're using an ultrasonic cleaner, which I don't think is necessary. As long as it's good enough, I would think it's good. So it's nice and clean, no longer all sticky. So let's go ahead and test this out. All right, so now I have the board back in the housing. I have everything plugged in. I'm booting it up by plugging in the cable. Now, one thing to note is, all right, I just heard it connect to the PC, so we should have the home screen here in a second. There we go. So one thing I like to do first is check the bar up here. So the control panel from the corner, this might have a SIM card in, that's why it might be searching. I hope that's why. Let me pop out the SIM, yeah. So if I pop out the SIM, yeah, it does have a SIM, probably not activated. So let me put my own. All right, it's a Metro SIM, so my T-Mobile SIM hopefully works. But this is a key point here. No SIM card means baseband is working. Baseband is not working, it'll just be forever searching or no service. So here's how we know everything is working. We got T-Mobile, LTE, we have Bluetooth and Wi-Fi not grayed out. You just give it, sometimes it takes a little bit for the T-Mobile service to be fully functional, so you'll see it cut off and come back on. So let's do another test. Dial 611 customer service. No grayed out speaker. I get some sound.
How can I help you today?
Billing.
Just to be sure, are you calling about your bill?
So yeah, everything seems to be working. Let's check everything else. 1x and 0.5x is working. Selfie camera is working. If we go to Wi-Fi, full Wi-Fi networks, Bluetooth, TV detected. Cellular obviously is working. Let's check Face ID. Face ID is working. So yeah, this is a fully working phone and ready to get back to the customer. So there you have it. We fixed a sandwich issue on this iPhone 11. We fixed a pad using the Refox Soldering Lugs, and we got a fully working device. Thanks everyone for watching. I hope you found this video helpful. I know sandwich boards are a little intimidating to a lot of repair shops, but if you need this done, I could do this for you, whether it's your personal phone or your repair shop looking to outsource this repair to somebody else. We do offer quick service, lifetime warranty, free return shipping. So send me a message if you need a quote. Also down below in the description, I'll link to all the tools, the sandwich splitter, the tweezers, the soldering lugs I use to repair the pads, all that good stuff. And this t-shirt as well will fix your phone for Bitcoin. So I do accept cryptocurrency as payments, whether it's Bitcoin, Ethereum, basically any coin, just let me know. I offer a 10% discount for anyone who pays with crypto, regardless of what the price of crypto is at that moment. So thanks everyone for watching. Make sure you smash the like button, subscribe to the channel, share this video across all the Facebook groups that cover phone repair, and make sure you join my Facebook group if you have any questions about any kind of repairs. I think that's pretty much it for me today, so I'll see you in the next one.